Today we are going to discuss about light reflection and refraction. Light reflection and refraction chapter we are going to discuss in this class. Okay, so now light reflection and refraction related to plane mirror, regular reflection, irregular reflection. Everything we'll discuss. So we'll see. Okay, so light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. So we are talking about light. When the object is so in the light reflection and diffraction topic, light reflection and diffraction topic, mainly we'll discuss about how the light will fall, how the reflection takes place, how the incident ray, reflected ray, how it is related, plane mirror, image formations. Okay, and everything we'll discuss now. We can observe, we can see. Mainly in this chapter, so units and mentions for JE NEET students, grade 11. So it is live class every day in YouTube channel. Every day. Here, now we are discussing about light reflection refraction chapter. Light reflection and refraction chapter. Light reflection and refraction. Light reflection and refraction. Light reflection and refraction. Light reflection and refraction. In this, light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. When light incident on the surface, it reflect back into the same medium. So I'm considering here this is a plane surface. Light is incidenting on the surface. I'm taking this one. This light is incidenting on the surface. Okay. So this is a plane mirror, highly polished smooth surface is called a highly polished smooth surface is called a plane mirror. So I'm considering this is a smooth surface. So that is a plane mirror. I'm considering plane mirror. When the light is incidenting on the surface, so this is the incident ray. The light which is incidenting on the surface, this incident ray, and it will be reflected back. So this I am considering the incident ray. And this I am considering the reflected ray. Okay. So the light which is incidenting on the surface, this incident ray. The light which is reflecting back, that is called reflected ray. So if you draw the normal line, so this perpendicular to the surface, this is the normal line. Okay, normal to the surface. So if you are drawing, if you are extending these points, so incident ray, reflected ray, normal. incident ray, reflected ray, normal, and this is undeviated line. So the light will passes. So normally light moves in a straight line path. In homogeneous medium, light moves in a straight line path. In homogeneous medium, light moves in a straight line path. Light moves in a straight line path. So like that, if you are taking this initial direction of the incident ray or undeviated line. The angle between incident ray and normal line is called angle of incident. Angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. Angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and deviated line is called angle of deviation. So this undeviated line. So angle between reflected ray and undeviated line. Undeviated line. Hi. Hi ma. So Ram. So how are you? So did you inform your friends? So classes are going on. Sir, you forgot to keep class from 4 to 5 electromagnetic waves. Yeah, you didn't confirm. No, I said to this number you can join to the, you can confirm to me. Then I will take the class. I said no. You know, from your side I didn't get confirmation. That's why I didn't conduct. Otherwise I will take the class. See, this is also one of the student asked. That's why I started this class. This class is not scheduled. Yesterday in the class they asked me. So sir, please explain light reflection and diffraction. That's why I planned this class now 6 o'clock. Okay, so let me know. So preferable time, as I said, so if everyone are saying yes, we will join to the class. Definitely, I will take. Okay. Okay, fine. So it's fine. So next, incident ray. This is normal line. This is incident ray, normal line, and reflected ray. Incident ray, normal line, reflected ray. So this is the undeviated line. Undeviated line I am considering. The angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. And angle between reflected and undeviated line. Reflected and undeviated line is called angle of deviation. Angle of deviation. So angle of deviation. So the bouncing back of the light, reflecting back of the light from the reflecting surface is called reflection of light. So actually it is also called reflector. This is called reflector because so the reflection of light taking place at this point. So that's why light is reflecting. So the surface is reflecting the light. That's why it is called reflector. So incident ray, reflected ray, normal line, undeviated line. Incident ray, reflected ray, normal line, undeviated line. Incident ray, reflected ray, normal line, undeviated line. Right? So this is about the bouncing back of the light. Okay, done. Sure. So we'll plan. Just let me know. Join to the 9 o'clock class also. I'm taking the class. Even 6 o'clock also. Okay. So join to the class. Keep on join. Keep on contact with me. So then we will be in touch with me. Then we'll work out on it. So classes, and inform your friends also. Ask them to join. So get the concept. Okay. So incident ray, reflected ray, normal line. So undeviated line, the angle between incident ray and normal line is called angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. So laws of reflection. So laws of reflection. So I'm considering. Anand, are you there? So you asked me to take the class, right? I'm taking. So are you there? Just let me know if you are there. Anhad. Okay, done. So come to the point. So angle of first point is loss of reflection. Loss of reflection, sir. Angle of incident is equal to angle of reflection. First point is angle of incident is equal to angle of reflection. Second point is angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. And second point, if you are considering incident ray, reflected ray, normal line lies on the same plane. So angle of incident equal to angle of reflection. Incident ray, reflected ray, normal line lies on the same plane. Okay, so incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. So this is about a loss of reflection. This is about a loss of reflection. This is about loss of reflection. Incident ray, reflected ray, normal line lies on the plane. So incident ray, reflected ray, normal line lies on the plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So this is about what is that? Loss of reflection. This is about loss of reflection. This is about loss of reflection. I hope it is very clear to you all. So next topic, next one is here angle of deviation. We have to find out angle of deviation. So I'm considering here angle of deviation. Normally, if you are taking angle of deviation, so this is the linear angle. Linear angle is 180 degrees. Linear angle is 180 degrees. If you are taking the linear angle in this case, so here this is the combination of angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So here you can consider angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So like that. So we can take angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. So from loss of reflection, angle of incident plus angle of incidence plus angle of deviation equal to 180 degrees. 180 degrees. So angle of deviation equal to 180 degrees minus 2 angle of incidence. So in the same case, if you are taking angle of deviation equal to 180 minus 2 angle of reflection. 2 angle of reflection. So instead of angle of incidence, I took angle of reflection. So that is the reason. Multiplier. Hi. Yes, sir. Huh? What is your name here? Multiplier. So here angle of deviation equal to 180 minus 2 angle of incidence. So here can I know your name? It's better to call. Yes. Hey, hi. Yes, how are you? Welcome to the Student the Brand channel. So we are talking about the light reflection and diffraction chapter. So we're discussing. So now 6 o'clock only started. Hello. Fine, sir. Okay. Nice. So here angle of deviation equal to 180 minus 2 angle of incident. Angle of deviation equal to 180 minus 2 angle of reflection. So this is about angle of deviation. So angle of deviation formula. Okay, incident ray, reflected ray, normal line, and this undeviated line. So undeviated line. So the angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. Angle of deviation. So this is about angles. Okay. So and the angle of deviation formula is and the loss of reflection. So angle of incident equal to angle of reflection. Sir, where are you from? So I am from Hyderabad. So here incident ray, reflected ray, normal line lies on the same plane. Okay, so this topic. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Nice. Thank you. Thank you so much. Okay. So next one, we are going to the next one. Regular reflection and irregular reflection. Regular reflection. Regular reflection. Irregular reflection. When the parallel beam of light incident on the surface, reflected beam also parallel. A reflected beam also parallel. Reflected beam also parallel. So I'm taking these are the incident rays, incident rays, incident rays, incident rays, incident rays, incident rays, incident rays. No, then we'll get reflected rays. So reflected rays. The action is Incident rays falling on the surface. Reaction is reflected rays will come from the surface. Nice, no? So here, this I am taking incident ray. Incident rays are parallel or incident beam, incident or incident parallel beam. I am taking incident parallel beam, here reflected parallel beam. So beam is different, diverging beam, convergent beam. So here incident parallel beam I am taking. Incident beam is parallel, incident beam parallel or parallel incident beam also we can take. Okay, so incident parallel beam. So incident parallel beam. So here also we can take. So here also reflected light rays also reflected light rays also parallel. Reflected light rays are parallel to each other. Reflected parallel beam we can say. Okay, so incident parallel beam. So here also reflected parallel beam. So parallel beam I'm considering like this. Okay, whenever the light rays are incident, Devidas Deva. Hey, hi. Naresh Sharma, hi. Uh, uh, Devidas, hi. Adar Singh, hi. Yeah, everyone, hi. Those who are joining, hi, hi. Okay, creator said hi. Oh my god. Hi, creator. Hi, everyone. But hi, everyone. Join to the class and just okay, listen to the class. If you have any doubts, you can ask. So regular reflection. Regular reflection is nothing but when the incident beam is parallel, then reflected beam also parallel. This type of reflection is called regular reflection. This type of reflection is called regular reflection. Regular reflection. Incident beam is parallel. Reflected beam is also parallel. This type of reflection is called regular reflection. Regular reflection. Next one, we are going to the irregular reflection. Irregular reflection. Irregular reflection. What is that? Irregular reflection. So when the light rays falls on it. So if I am taking here, if I am considering here, okay, so this incident parallel beam, incident parallel beam, reflected beam is not parallel to each other. Okay, reflected beam is not parallel to each other. Actually, थोड़ा थोड़ा हिंदी आता, so थोड़ा थोड़ा हिंदी समझ आता, so okay, so reflected beam if you are taking like this, so and namaste. Hey, hi, class 9, very good. So in class 9 also, motion, force and loss of force and we can take, and gravitation, sound, yeah, different topics are there. 3 type of reflection. Hey, Agarwal, 3 type of reflection. What is third type of reflection? Can you tell me? Naresh Sharma, hi. What is 3 type of reflection? Can you tell me? So everyone, those who are joining to the class, so please do like, share and subscribe to Student the Brand. So you'll get further extraordinary classes and you can get the concepts. And the 9 o'clock class you can join. Everybody 9 o'clock class you can join. Okay, that time I'll be explaining the topics. Okay, so you can join to the class. Yes. So what is Agrawal? Can you tell me? What is our name? Namaste. Class 9. Uh-huh. Oh my god. Hey, physics. Logical answer. You know, in Robo movie, he will ask one question. So place a triangle on square. It is possible. But when he asks the same question, place the square on triangle. So it is hypothetical question. So Agarwal, he given one extraordinary answer today. So I have to learn that one. What he said, I am explaining two reflections. So he said third reflection. So what is third reflection? The third reflection is invisible. Namaste, boss. Marvelous. Nice. Okay, so come to the point. Next one, irregular reflection. So here, reflector light rays are not parallel to each other. Reflector light rays. Have you cracked? Yeah, neat. Yes, here Siva sir, BTech mechanical. So I completed so mechanical BTech. So 10 years experience in physics teaching. 10 years experience in physics teaching. Okay, so that is my qualification for teaching. Okay, maybe I'm thinking I'm eligible for teaching. Okay, so okay, here I'm taking, these are the incident rays, these are the incident rays, these are the reflector light rays, these are the reflector light rays. See, reflector light rays are not parallel to each other. Good evening, sir. Yes, sir. Home Kumar. Hey, hi, good evening, Om Kumar. Welcome to the student, the brand. Welcome. See, my profile already placed, so everyone can see, right? I already wrote my profile. So by CBSE Grade-10 Physics, Siva sir, BTech Mechanical, 10 years experience in physics teaching. I kept in a broad letters, so separate space I mentioned. Okay, so you can see, everybody can see. Okay, come to the point. Next one. So those who came to class, so you can 9 o'clock also you can join to the 9 o'clock class. 9 o'clock. Okay, today every day 9 o'clock class will be there. So you'll get extraordinary concept. You can ask doubts. You can get the concept. Why don't you buy smart board? So I'll buy soon. I'll buy. Okay. So right now I'm planning. So soon you will get it. Soon you can see the smart board with me. Right, so done. So this is about reflector light incident rays. These are the reflector light rays. Reflector light rays are not parallel to each other. Reflector light rays are not parallel to each other. So this is the incident beam. Incident beam. Okay, it's only yes, yes, boss. So incident beam definitely Agarwal. So not one day. I can't tell so which day, but one day. So you come and join. If you see with me, only if you see me with a smart board, you can say thumb or appreciation or something. Okay, sir. Very hard work. Yes, multiplayer. What is your name? Can you tell your name? Yeah, here multiplayer like that mention. I hope you are a game player. Oh yes, 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 yes. So my one of my student name is also Yes. Yes, sir. Why you teach any offline institution? Actually, uh, yeah. Can I get okay? It's Agrawal, right? Yes, yes. This is some. My name is Summer. Okay, Summer. Summer, actually, I'm in Hyderabad right now. So here, see, I see if I take offline classes, so I will teach offline classes also. But if I'm teaching online classes, so I can meet wonderful people like you, talent people like you, so extraordinary people like you. Okay, so that's why. So I can meet more people, more talent people like you. That's why I'm taking online classes, right? Is it worthy answer? Definitely, it's worthy answer, right? So if you am considering here, incident beam is like this. So incident beam is parallel, but reflected beam is not parallel. Thank you. Yes. Reflected beam is not parallel. Reflected beam is not parallel. Okay. So this type of reflection is called irregular reflection. But Agarwal, whatever you said, that answer, mind blowing, boss. Really mind blowing answer. So even I couldn't able to imagine. I'm thinking, so which is a third type of reflection? How the third type of reflection will be there? Really, see, that's why I said no. You are extraordinary talented people. Okay, so that's why a regular reflection or a irregular reflection. So that's why I completed. And the next one, we are going to the next topic. Next topic. Next topic is about image and object. Image and object. So I'm going with the image and object. So if you are taking, I'm considering the regular reflection, irregular reflection completed. So we are going to the object and image. See, extraordinary concept it is. Sir, I am in 9th class. Can you teach me law of motion for 5 minutes if you are okay? Law of motion. So very simple only. So three laws, Newton's first law, second law, third law. So first law defines inertia, second law defines F equal to ma. So when external force acting on the body is equal to mass multiplied. Okay, so it is a product of mass and acceleration. So F equal to ma, and it is also change in momentum, the rate of change in momentum. The external force acting on the body is equal to the rate of change in momentum. So F equal to mv minus mu by t. So that is also nothing but impulsive force. Mv minus mu by t is nothing but impulsive force. Okay. So F into t. Change in momentum. Change in momentum also we can say. And third law, if you are saying every action there is a equal and opposite reaction. You ask the question, I said the answer. So your action, that is my reaction. That's enough. Is it clear? Sir, your number is out of service. Yeah, WhatsApp. WhatsApp. See, WhatsApp you can contact. So you can contact the WhatsApp. You can message. So right now I'm using the same mobile. You can. So instead of see, if many calls are comes, I can't able to handle. So even if I'm not able to answer, means the people will feel bad. That's why you can WhatsApp right now. Just try it once. Will you? Did you try? Sir, hello, sir. Please shout out, please. Huh? What happened, Jumeir Khan? What happened? You want me? Okay. So someone said Agrawal. Just you can send a message. If it is not reaching, then I will see. Is it reaching or not? Just let me know. Okay. If it is not reaching, definitely, sir. Please speak in Hindi. Hey, crick boy. So what is your name? हिंदी थोड़ा थोड़ा आता हिंदी में या yes Agarwal, I'm getting call. Sure, definitely. WhatsApp, I'm getting call. So it's online, no Nila. So after the class, I will respond to you. So if you want any classes or not, so you can drop the call. Agarwal, right? Yes. So I will reach to you. From where are you, sir? So I am from Hyderabad. Agrawal, sure, definitely I'll reach to you if you need any classes or anything, explanation or any tuitions like that online. So that number I will reach to you. Say hi to that number. WhatsApp, see, if instead of getting many calls, if you can't able to respond, it's a problem. So even students feel upset. That's the reason. So WhatsApp is available. So it is working. You can contact to the WhatsApp. So you'll get the messages. I will get reply. Sir, you are not able to speak in Hindi. Hey, kid boy. So I can speak here. I can speak. Surely I will learn and speak. What is? Actually, Om Kumar. So we know like one quotation. We speak English, we eat English, we drink English, we swim in English. So we bath in English, everything. So like that, so you can see my channel completely. It's related to physics only. Sorry for that. So related, no, even you can see everything related to physics only. If you have any questions related to physics, you can ask. Definitely, I will answer. So remaining subject, see, you can contact to this number. One more thing. So I had a great team. People are there with me. So you can contact to this number. Many people will they will teach remaining subjects also, like biology, chemistry, social, Hindi, like all the remaining languages. Okay, and including maths. Okay, so I have Om Kumar. So if you want any, you can WhatsApp to this number. Please try to WhatsApp this number because I can respond after the class. Yeah, definitely. Actually, I am in Bangalore. So ಸ್ವಲ್ಪ ಗೊತ್ತು ಮೇ ಮಾತಾಡ್ತಿ ಸ್ವಲ್ಪ ಗೊತ್ತು Jamil Khan. Sir, can you explain resistor in parallel? Hey, Agrawal, you said someone asked. Okay, you only asked 9th class. Yeah, see, I'm explaining a light reflection diffraction, right? I will explain. See, in the previous classes, just now 2 days back, I hope. No, yesterday only, complete chapter I explained. Anand sir, oh, Anand. Hey, Anand. Hey, Anand, are you joined? So actually, I'm waiting for you. I'm taking class for you only, right? So why didn't you respond from starting onwards? I thought you are not there. So continuously, I asked also in class. I don't ask for ninth class. I am currently in 10th. Okay, 10th. Okay, then. So you can WhatsApp to me. So this number, anyway, you WhatsApp, right? I will reach to you. So remaining everything, I will explain. Agarwal, I don't ask for ninth class. I'm okay, currently. Study obsessed. Hello, do you speak Telugu? చెప్పండి బాస్, ఏంటి సంగతులు? మీ పేరేం చెప్పండి కొద్దిగా. Okay, Anhad. So I will continue, Anhad. Just I will respond few messages and then I will continue. So స్టడీ అబ్సెస్డ్ 10th D. మీరు చెప్పండి గురుగారు, మీ పేరు చెప్పండి గురుగారు. అనుకున్నావా? ఏ జోక్స్ వేస్తున్నావా? అనుకున్నా ఏంటి? యువర్ నేమ్ ఈజ్ అనుకున్నానా? Okay, fine, no problem. So I will continue the class. So still, if anything is there, let me later I'll respond. So just focus on class. So those are there 10th class. I hope so. So students, so many students are joined now. I will continue the class. Hello, sir. Hi, Shivani. How are you? Join the class. Okay, done. So we'll continue the class. Light reflection and refraction. So now I am explaining about object and image. Okay, so okay, study obsessed 10:30 definitely. So if any help regarding the classes, regarding the online tuitions, you can just contact to this number. WhatsApp immediately. You can WhatsApp to this number. I'll respond because calls. So too many calls if it is not possible to the number. Okay, to WhatsApp it will be available. You can WhatsApp to this number. Definitely, I will reply to you. Okay. Then if you are taking here, so here I'm considering this the object. This is the object. This is the object I'm taking here. This is the object. When you are taking the object, so how many light rays are required to form the image of the object? Minimum 2 light rays are required. So I'm considering here like this. So this is a object. This is object. Light rays are inciding on it. It will be reflected back. So if you are extending these light rays, those light rays will meet at one point. So this is the real object. And this is the virtual image. So this is the real object and virtual image. So reflector light rays are meeting at one point. Okay. So here real object, and one more I'm considering here. So here I'm taking the object. Actually light rays are coming from infinity like this. So after reflection, those light rays will meet at one point. So if you are extending these light rays, here, this is the incident ray and this also incident ray, I1 and I2. So this is the R1 and R2. Okay. So if you are extending these incident rays, these are the incident rays. Those incident rays are meeting at this point. So that is a virtual object. Here you can see. So here the incident light rays are coming from the point. So after reflection, those light rays will meet at one point here. The reflector light rays are like this. After reflection, those light rays are meeting at one point. So their virtual image will form. Here virtual image will form. Here virtual image will form. So the point of intersection of reflector light rays. Is called. The point of intersection of reflection light rays is called. So live I'm explaining reflection. After completion of this one, lens I will go. So nearly it will take now 6:30, so it will take until 7:30 or 8. So be patient and listen the class. Ashwini, hi, how are you? Welcome to the student the brand. Okay, come to the class so we can everybody join to the class and understand the class. So may focus on the class because all are important topics, all are important concepts we are teaching right now. So this is very very important. 3 marks question will come definitely. So either image and object. Okay, so image and object. So related to this concept, one question definitely will come in the exam, board exam point of view. So one question will come. So related to object and image, real object and virtual image, real object and virtual image, how it will form, the where it will reflection takes place, everything we will discuss now here. See, so these are the incident rays. These are the incident rays. So after incidenting, this reflector light rays will be there. If you extend this reflector light rays, yes, ma, you can join. You can call and ask them to join to this class. So you'll get extraordinary concept until 7:30 or 8. Be patient and be in the class until 8 o'clock. Until 8 o'clock. So nearly 1.5 hour it will take. So nearly 1.5 hour it will take. Ask your friends to join to this class. Remaining students also, those who are there in the live class. So you can ask them to join and so this class continue. Generally 1.5 hour I'm expecting. So if it is complete in before only it is fine, but my expected time is 8 p.m. Okay. So these are the reflector light rays. So after reflection, those light rays will meet at one point. So their virtual image will form. So here virtual image will form. Okay. Reflector light rays are meeting at one point. Reflector light rays are meeting at one point. So that is called virtual image. Here you can understand these are the incident rays. These are the incident rays. So this make a note of. Okay. So I can't keep it like this right permanently. So try to take a notebook and write down. So I'm requesting everyone, those who are there in the live class, try to note down the points. Whatever I'm saying, the points are extraordinary points. Sir, I'm going on. Okay, World Cup Champions. All the best, Bhavesh. Gautam Kumar, hi. All the best, Bhavesh. Good luck. So, best of luck for your life and for future. Okay, here reflector light rays are meeting at one point. Reflector light rays are meeting at one point here. So by this by this observation we can conclude that very very important point. Very very important point. Next concept is interlinked with this. Next topic, whatever I am saying, next topic. Sure, sir. I have copy. Oh, okay, very good. So copy. Bhavesh, thank you so much, sir. Very good, ma. I am already making notes. Extraordinary, Jamir Khan. So very good. Those are writing. Very nice. Make a note of it. Extraordinary concept I will give. We have to tell what exactly the concept, what exactly the class. So definitely we have to understand. So very very important concept. Extraordinary concept it is. So make a note of it. Learn it. So here I'm considering the object and image. Here you see these reflector light rays are meeting at one point. Reflector light rays are meeting at one point. Reflector light rays are meeting at one point. So their virtual image is forming, right? So observe carefully. Reflector light rays are meeting at one point. So their virtual image is forming. Here the incident light rays are coming from this point. Incident light rays are coming from that point. That is a real object. Incident rays are coming from the point. That is a real object. Reflector light rays are meeting at one point. Reflector light rays are meeting at one point. There virtual image. If you this is one and this is one example. So first one, and coming to the second case. So here incident ray, we are extending the incident rays. Here these are the incident rays. Incident rays. So here these are the incident rays. We are extending the incident rays. The extended incident rays are meeting at one point. There, Gautam Kumar, hi. So there's incident ray. These incident rays are meeting. That is a virtual object. What see? If the dotted lines meet at one point. So remember carefully. If the dotted lines meet at one point, their virtual image will form. You can see anywhere in coming concept also. If you are taking plane mirror and lenses also, concave mirror, convex mirror, and convex lens and concave lens, anything you can take. If the dotted lines meet, means extension light rays, extended light rays meet, then that their virtual object or image. So depending on the light rays, if the extended incident rays, if you extend their virtual object. If reflector light rays are extending, that is a virtual image. So I hope it is very clear. Now object is real. If the object is real, here this is the object, real object. What about image? Image is virtual. If the object is virtual, so object is virtual. This is the virtual object, right? What about image? Image is real. Image is real or not? So image is real. This is the real image. Object is virtual. Image is real. Image is real. Object is virtual. Image is real. So very, very, very important. Very important. Okay. And here you will get the definitions of real object, real image. The point of intersection of reflector light rays. The point of intersection of reflector light rays is called real image. The point of intersection of reflector light rays is called image. The point of intersection of reflector light rays is called image. The point of intersection of extended incident rays. The point of intersection of extended incident rays. Here these are the extended incident rays. These are the incident rays. We are extending those incident rays. Those incident rays are meeting at one point. Their virtual object. Here the point of intersection of reflector light ray. The point of intersection of reflector light ray. So this reflector light rays are meeting at one point. Their virtual image is forming. So this table is very important. Table is very simple, but concept is too big. So naam chota, sound bada. So you know the dialogue, right? So here is same thing with the reflector light. So these are the incident rays. So these are the reflector light rays. So here the reflector light rays are directly meeting. Here extended incident rays are meeting. So here dotted lines meeting, virtual. Real light rays, real object. I hope it is very clear. So because this is very, very important concept. नाम छोटा का बड़ा लेकिन साउंड बड़ा आता है. Okay, now so light reflection and diffraction. So object and real object and virtual object, everything we discussed. So now we are going to the plane mirror. So characteristics of the image formed by the plane mirror. Very, very important, definitely. So this question will come for 3 marks. So I am telling this question will come for board exam 3 marks question. Very, very important concept. Okay, so in this I am going to teach 3 points. Those 3 points, so in MCQ's point of view also very important. MCQ's points also virtual and direct, always plane mirror. Yeah, that only. 3 marks, and at the same time 3 points I'll discuss. Those 3 points will come expected as a 1 mark question in the board exams. So whatever I am saying, all the important concept only, make a note of it. Okay, make a note of it. So here I am considering the plane mirror. So I am considering the plane mirror like this. I am considering the plane mirror. Okay, so here I am taking the object. I am taking the object here. This is the object. This is the object. This is the object. So this is AB. Okay, so that is the height of the object. Chaitali. Okay. Height. Okay, so I'm taking this AB. 1 liter I am taking like this. If your friends, ask them to join to the class, because coming until 8 o'clock class is there. So extraordinary, marvelous. So very depth will go to the concept. So board exam expected questions I will teach, and where we have to concentrate, how they will ask the question, how we have to answer, and even for slip test, mid test, and unit test, any test, whatever I am explaining, these concepts will be helpful. So ask your friends, inform to your friends. So share this link to your friends as much as possible, because if you are delaying late, automatically the concept will go on. So yes, even though after class also it will be uploaded, but when your live class is going on, if you interact, it is better. No, we can understand better, we can ask questions. Okay, I will explain according to the questions. So here I am considering how many light rays are required to form the image of the object. Minimum 2 light rays. So minimum 2 light rays, and like the video also, like the video, it will spread to remaining students also. They will also join to the class. So 2 light rays are required. 2 light rays are required. How many light rays are required to form the image of the object? Minimum 2 light rays. So I'm taking one light ray here, another light ray I'm taking like this. So normally you see here, normally you can see here, I'm taking this a plane mirror. So this is a plane mirror. Normally if you are taking, when the light is incidenting along the normal line, if the light is incidenting along the normal line, so it will be reflected back. So this question will come for 1 mark. This question will come for 1 mark. They will ask about this question. So whatever I am saying, this question will come for 1 mark. What is that? So what is the angle of incidence? In this case, what is the angle of incidence? What is the angle of reflection? And what is the angle of deviation? So among these 3 points, any one question they will ask. Among these 3 points, any one question they will ask. Among these 3 points, any one question they will ask. So if the light ray is passing along the normal line, if the light ray is passing along the normal line, if the light ray is passing along the normal line, so what is the angle of incidence? First point. What is the angle of reflection? Second point. What is the angle of deviation? So among these 3 points, definitely one question may ask, because 1 mark question is very, very important. So when the light ray is passing along the normal line, mostly which will be asked. So angle of deviation they will ask. Generally they will ask angle of deviation. Why it is so special? What about angle of incident and what are angle of reflection? Why only angle of deviation? The point is, so we know angle between incident ray and normal line is called angle of incidence. Angle of incident. Angle between reflected and normal line is called angle of reflection. So if the light ray is passing along the normal line, by default we can understand angle of incident, angle of reflection is both are 0. Angle of incident and angle of reflection is both are 0. But what about angle of deviation? No idea. We'll get fully confused. So how we can identify the angle of deviation? That is a problem. Normally by default we can understand, by seeing the diagram only we can understand angle of incident is 0, angle of reflection 0. What about angle of deviation? That is the reason they will ask this question. Angle of deviation. What is the angle of deviation? What is the angle of deviation? They will ask. What is the angle of deviation is? How much is the angle of deviation? Angle of deviation is 180 degrees. So what is the angle of deviation? Definition. If you are taking this incident ray, reflected ray, and this is a undeviated line. So the angle between reflected and deviated line is called angle of deviation. So here you see, if the light ray is passing along the normal line, so the reflected ray retraces its original path, means it moves along the same line, So this is the deviated line, right? Deviated line will be downwards. Okay, so if it is moving, it is passing like a straight line, right? Okay, like a linear. So rectilinear propagation of light. There are 7 properties of light: rectilineation, reflection, refraction, diffraction, interference, polarization, photovoltaic effect, like that. So here also, if the light ray, according to the reflection of light, rectilinear propagation of light moves in a straight line path. There are properties. So light moves in a straight line path. Okay, done. So here, this is a reflected ray and this is a undeviated line. So the angle between reflected ray and undeviated line is called angle of deviation. So here is what is the angle of deviation? 180 degrees. 180 degrees. So that is the reason. So this angle of deviation is very special. Angle of deviation is favorite question for CBSE board exam. Why, sir? That is the main concept, no? That is only main concept. Okay. If you want to go for a 10th class, you have to go for 6th, 7th, 8th, 9th, 10th, like that. So they will ask like that only. So you only asked one question, right? So Jumeir, this is the answer, right? Okay, done. Fine. So, okay. So see here, we will go in depth of the concept according to your questions. If you ask questions, I can teach more in depth. Okay. So based on your questions, more concepts I can explain. Okay. So try to ask the question. If you have any doubts, don't hesitate. Try to ask. Try to post. Try to comment. Your face will not be visible, right? Only answer. So only question only, right? So post only, right? So in class, if you ask, maybe you feel shy. But here, so no need to hesitate. So you can ask with the proud. Okay. So ask your questions. That is your right. What is the basic right? like human rights, children rights, like that. This is a basic right. Okay. Come to the point. So I'm considering here. So this is the incident ray, reflected ray. This is also incident ray, reflected ray. So if you are extending this light rays, and here also if you are extending this light rays, okay. So this is the incident ray, reflected ray. This is also incident ray, reflected ray, and I am considering here. So how many light rays are required to form the image of the object? This is also very important. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. So I am extending this light ray. So here image will form. So we are extending this. Okay. So here virtual image will form. Virtual image will form. Right? Virtual image will form. So ask your friends to join to the class. Again, I'm saying very important concept we are discussing. So this is the A dash and B dash. So this is AB, A dash and B dash. So this is the object and this one is the image. So here I'm taking. So this is the object. This is the object. And this one is the image. So image. So object and image. Okay. So here this is the object, real object. This is virtual image. So here the distance between generally mean. Okay. Some of the students not able to understand. Yes, ma. So some of the I will explain image size. I will explain. So here some of the students basic point is, so the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Okay, no? So these basic points few people not able to understand, not able to recognize, not able to learn it. That is a problem. Very basics. So try to learn this basic. Okay, now. So very important concept it is. 3 marks question, 3 marks question, or 1 mark question, or 2 marks question also will come for board exam. I will tell which question they will ask for 3 marks, which question they will ask for 1 mark, which question they will ask for 2 marks. So first point is, as I said the previous concept, I said no, object is real, image is virtual. Image is real, object is virtual. Vice versa. I said no. Here also same thing. If the object is real, image is virtual. If the image is real, object is virtual. Vice versa. So in plane mirror, so vice versa it will take place. And the second point is object is real and virtual. So vice versa it will take place. So double arrow mark like that. And the second point is object distance is equal to image distance. Object distance is equal to image distance. And coming to the third point is height of the object is that is size of the object. Height of the object is equal to height of the image. Height of the object is equal to height of the image. Very most important points. MCQ's point of view, questions point of view. There are many questions they will ask in so on this concept. Many questions they can ask on this concept. So in plane mirror, object distance is equal to image distance. As you move object near to the mirror, so image also will move inside of the mirror. Image also will move. Object distance is equal to image distance. And the height of the object is equal to height of the image. If you take 5 centimeter, so 5 centimeter if you are taking, image also will be 5 centimeter, 10 centimeter, so 11 centimeter. So we are in 10th class. So 10 centimeter, here also 10 centimeter. So like that, height of the object is equal to height of the image. So here object distance is equal to image distance. So very important. And one more thing also, it shows the lateral inversion. So what is the lateral inversion? The phenomena of Lateral inversion is nothing but the phenomena of converting of the right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. So once again, right side of the object appears to be left side of the image, right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. So this mirror image is called lateral inversion. So best example, you see the ambulance, how they will write on the vehicle, so front of the vehicle. So when you see in the rear view mirror, it appears proper. That is a mirror reflection. Even if you stand in front of the mirror and lift your right hand, it appears in the left side. So right hand object appears to be left side of the image, left side of the object appears to be right side of the image. This mirror conversion is called conversion is called lateral inversion. Very very important. So and also based on this one question will come. Okay, so what is that question? From A to Z, from A to Z, which letter will show lateral inversion, which letter does not show lateral inversion? So if anyone knows, so you can drop a comment. Once again, think about it. So after, if you want to listen the class, and so take some time and you can drop. So once again, so which letter will show, which letter will does not? So we'll go for a which letter does not show lateral inversion. We'll go for which letter does not show lateral inversion. From my end, I am telling any one person can say one letter. So I'm saying O does not show lateral inversion. Simple, no? O does not show lateral inversion. If you place in front of it, it will appear O only, no? So left side, right side, left side, we can't able to recognize. So O will not show lateral inversion. So if you know the answer, so you can comment. Okay. So from A to Z, which letter does not show lateral inversion? So I also, capital letter I. Capital letters. So go for capital letters. Okay. So I'm not talking about the small letters. So you can go for capital letters. In capital letters, which letter does not show lateral inversion? All the best. Okay, so this is about lateral inversion. So if the object is real, image is virtual. If object is real, image is virtual. If image is real, object is virtual, vice versa. So object distance is equal to image distance. Object distance is equal to image distance. Object distance is equal to image distance. And the height of the image is height of the object is equal to height of the image. Height of the object is equal to height of the image. So here only this case, especially I'm telling one point here, because actually in end of the mirrors it will come. But now only I am saying the magnification is height of the object by height of the image. That is nothing but +1. So only in the plane mirror we will get +1. Only in the plane mirror we will get +1. Okay, magnification is positive. Magnification not only positive, it is +1. +1 will get. -1 also will get in a concave mirror and convex lens. But +1, positive value +1, because only in the plane mirror, height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. Or size of the object is equal to size of the image. That's why magnification is +1. Mark here, right here itself, magnification. After getting know that concept, so once you are revising, right, when you are revising, by seeing this point, you can recognize, you can recall, you can remember very well. So for the board exams, it will be very easy. You can immediately write this point. So very, very important point, very powerful point. So very effective point, this point. Magnification is +1. So where you will get? So this diagram also they will ask. I said no, 3 marks, 1 mark, 2 mark, where they will ask. 1 mark question. I will start with 1 mark. 1 mark here. So magnification, related to magnification question they will ask. And coming to the 2 marks, lateral inversion question they will ask. For 2 marks, lateral inversion. And coming for 3 marks. So which question, how they will ask for 3 marks? So write the characteristics of the image. Write the characteristics of the image formed by the plane mirror. Write the characteristics of the image formed by the plane mirror. So you observe here 1 mark, 2 mark, 3 marks. 1, 2, 3. So in a sequence, in a row. So we'll get questions from this concept. Very, very extraordinary concept. Extraordinary concept. So very important. Make sure that write a notes. Write a notes. Prepare well. Okay. Write a notes. Prepare well. If you have any doubts, you can ask me. Okay. The diagram also very important. Diagram also very important. Right. The next one, we are going to the next one. So I'm erasing. So next one, spherical mirrors. So inform to your friends, ask them to join to the class. I said still 1 hour is there. So I hope 1 hour also not sufficient for us, because that much concept is there. Still we need to go long. So I'll try to finish by 8 p.m. So if not, because 9 o'clock again I have class. 9 o'clock again I have class. 9 o'clock. So if it is possible, I'll finish. Otherwise, 9 o'clock class you can join. I'll continue the class if it is possible, because now 7, nearly already 7. So maybe the concept is still so much is there. I will try to work out. Okay. So I'm considering here. So this is the sphere. This is the sphere. I'm taking the portion. There's a small portion like this. This is called curvature. This is called curvature. This is called curvature. I'm taking the curvature like this. It is called curvature. Okay. So that is called curvature. I'm taking here. This is a curvature. Curvature. It is a part of the sphere. 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 Okay. So here the center of the sphere will be there. Center of the sphere. What is the center of the sphere? So here I'm considering here a spherical mirror. So I'm taking the spherical mirror, right? So this one portion, small portion, that is called spherical mirror. What is the definition of spherical mirror? The mirror which is in the form of curved shape. The mirror which is in the form of curved shape, that is called spherical mirror. The mirror which is in the form of curved shape, that is called spherical mirror. There are two types of mirrors are there. So two types depending on the reflection, 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 depending on the reflection. So I am taking here. So this is a concave mirror. Reflection takes place inward. 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 That is the reason concave mirror is also known as converging mirror. Converging mirror. Concave mirror is also known as converging mirror. Converging mirror. Converging mirror. Converging mirror. Mirror. Converging mirror. Yes, so concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Sir, why your concave mirror is also known as converging mirror? Why? Any specific reason? Yes, specific reason is there. When light rays incident on it, when the light rays are incidenting on it, it reflected. It will be, those light rays will reflect and meet at one point. Because the light ray after converging, those light rays will meet at one point. Okay, so those light rays will be reflected at one point. So those light rays are moving towards the principal axis. Best example, you are coming from different place to school, or college. So you are coming from different place to school or college. Okay, so you are converging, means converging, coming to one place. So in evening time, you see you are moving from one place to in different places. That's a diverging. So here, whenever the light rays falls on it, whenever the light rays incident, and those light rays will reflect and meet at one point. So that is the reason this is called concave mirror. That is known as converging mirror. So convex mirror. So you are taking the convex mirror. Convex mirror. So convex mirror, you see. So convex mirror. I am taking the convex mirror. This is a convex mirror. I am taking the convex mirror. Convex mirror. Mirror. Convex mirror. Anybody want convex mirror? Everybody want, because you people are writing board exam. So if the light ray incidenting on it, it will be reflected back. So it will be reflected back. So those light rays will meet at one point. So here I am considering those light rays will meet at one point, right? Those light rays will meet at one point. Reflected. So extension of reflected light rays. So here you can understand by seeing this diagram, this reflection takes place outward, reflection takes place outward. Okay, so outside is the reflecting surface. Whenever the light rays incident on it, it will be reflected back. It will be reflected back. Those light rays are moving away from the principal axis. Those light rays are moving away from the principal axis. Those light rays are moving away from the principal axis. So that is the reason it is called diverging mirror. So convex mirror is also known as diverging mirror. Convex mirror is also known as diverging mirror. Diverging mirror, diverging mirror. Convex mirror is known as diverging mirror. Diverging mirror. Yes, convex mirror is diverging. Sir, why you are saying convex mirror is diverging mirror? Why can't you say only convex mirror? Because so whenever the light rays incident on it, those light rays are moving away from the principal axis. So diverging, moving away from the principal axis. So after school or college, you are moving away from the institution, right? You are going to home. That is a diverging. Here also same thing. Okay, so whenever the light rays are incident on it, it will be moving away from the principal axis. If two best friends, so if some clashes comes, then what happens? They will move away, diverging. That's the reason. Okay, so if you are taking here, so I am considering here like this. Okay. So I am considering concave mirror and converging mirror. Concave mirror and convex mirror. So we described how it is. So what is a concave mirror and what is convex mirror? Next one, ray rules. Ray rules I'll take. See, if you are going to war, we need weapons. Yes or no? If you are going for war, you need weapons. If you are going to exam hall, you need content to write on the exam. Okay, if you want to get good marks, you should study well. Right here also same thing. If you want to draw the image formations, you need ray rules. These are the ray rules. These are required. Okay, so I'm explaining ray rules, very important ray rules. So practice with me, draw with me. So ray rules of concave mirror. Ray rules of concave mirror. So I'm considering concave mirror like this. So here I'm considering like this. So here is the pole, focus, center of curvature, pole, focus. See, before that we need to explain about, we should discuss about related to spherical mirrors. Okay, so we'll discuss terms first. So before, without explanation of terms, if you go to directly that one, so it may be not effective. So I'm considering here. So this is a concave mirror. So this is the part of the sphere. This is a concave mirror. It is a part of the sphere. Concave mirror, part of the sphere. Concave mirror, part of the sphere. Concave mirror, part of the sphere. Part of the sphere, part of the sphere. Yes. So for this, center will be there. Center will be there. That is the center of the curvature. So center of the imaginary sphere. Once again, definition. First point, center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. Okay, so now the midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The line joining of center curvature and pole is called principal axis. Second one is pole. First one is center curvature. Second one is pole. Third one is principal axis. Principal axis. Principal axis. Principal axis. And fourth one is the distance between center curvature and pole. The distance between center curvature and pole is called radius of curvature. The distance between center curvature and pole is called radius of curvature. Okay, so fourth one is radius of curvature. And coming to the fifth one, after reflection, all light rays will meet at one point. After reflection, all light rays will meet at one point on the principal axis, that is called focus. So simply we can say principal focus. So this is also called principal focus. Simply we can say focus. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis, that is called focus. That is called focus. That is called focus. That is called focus. So the distance between focus to pole, the distance between focus to pole is called focal length. The distance between focus to pole, the distance between focus to pole, the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. So see the center of the imaginary sphere. See the center of the imaginary sphere in which mirror is apart. I am taking the concave mirror. So as I said, coating is very important. Whenever you are drawing the concave mirror, you must coat outside. So reflection takes place inward. Center of the imaginary sphere in which mirror is apart is called center of curvature. So the midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. So the line joining of center of curvature and pole is called principal axis. The line joining of center of curvature and pole is called principal axis. The distance between center of curvature and pole is called radius of curvature. The distance between center of curvature and pole is called radius of curvature. The distance between. So after reflection, all light rays will meet at one point. After reflection, all light rays will meet at one point. After reflection, all light rays will meet at one point, that is called principal focus or focus. So the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And coming to the seventh one, the width of the mirror, the diameter of the reflecting surface or width of the mirror, diameter of the reflecting surface is called aperture. 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 Once again, center of the imaginary sphere in which mirror is apart. Center of the imaginary sphere in which mirror is apart. So pole is the midpoint of the mirror. The line joining of center of curvature and pole is called principal axis. The distance between center of curvature and pole is called radius of curvature. So after reflection, all light rays will meet at one point on the principal axis, that is called focus. So principal focus also we can say. The distance between focus to pole is called focal length, that is nothing but small letter f. So here we need to understand that this difference, because the one is capital F, another one is small f. Capital F is the principal focus, small f is the focal length, and last one is the width of the mirror is called aperture. Diameter of the reflecting surface is called aperture. Diameter of the reflecting surface is called aperture, or width of the mirror is called aperture. So this is about terms related to spherical mirror. Terms related to spherical mirror or nomenclature. Nomenclature or terms. Nomenclature or terms related to spherical mirror. Right. So next one, we are going to the next one. So next point is we are going to the next topic. Ray rules. Ray rules. Ray rules. Ray rules. Ray rules. Ray rules. Nice, sir. Nice. कैसे हो? Hi. Can I know your name? So then we will talk with your name. Ray rolls. So your name, something is there. Pop, Blue, like that. So can I know your good name? So here I'm taking the concave mirror like this. Concave mirror, concave mirror, concave mirror. So who are you teaching to? Actually, if you see in the previous message, there are so many. So because of time being, they went. I hope so. They will join. So with the confident and hope. So I'm teaching, and you join. No, sorry for that. You join. No, for you only I'm teaching. So pole, focus, and center curvature. So still I didn't. Can I know your name? If it is with your permission. So I'm taking one light ray, I'm taking like this. After reflection passes through focus. And the second one you can consider. Second one I'm taking. My name is Rudra. Hey, hi Rudra, how are you? Welcome to the Student the Brand. So this is your Siva sir. I'm teaching physics, CBSE grade 10 physics. Today I'm talking about light reflection and diffraction, ray rules of concave mirror. So after see one light ray is coming from infinity, after reflection passes through the focus. So if you are taking another light ray after reflection, it moves towards infinity. And coming to the third one, Manikantan. Hi Manikantan, how are you? Hey Manikantan. Actually, my student name is also Manikantan. Are you a student of mine? So because so do you know me, Manikantan? So here I'm saying, so one light ray I'm taking here. So if the light ray passes through center of curvature, no sir. Okay, online. So what if I take a line from infinity not parallel to principal axis? Yes. So after reflection, it passes through focus only, right? You can take. So it is you can see that plane of focus. It passes through plane of focus. Plane in the sense normally see whatever we are seeing 2D, x-axis and y-axis. So there is a 3. So 3 dimension if you take through the plane it will pass. Are you agree with me? Still I didn't get Rudra. Rudra, are you agree with me? It passes through the plane of focus, Rudra. With my best regards, I said. Okay, sir. Thank you. Thank you so much for your confirmation. So I'm considering here. So this is the pole, focus, central curvature. So if the light is incidenting at the pole, it will reflect back. So these are the ray rules. These are the weapons. These are the weapons to us. These are the weapons. Very, very extraordinary weapons. 6 weapons. 1 weapon, 2 weapon, third weapon, fourth weapon. Sir, what is the use of these weapons? Next we are going to do war. Be ready with it. Who will come with me? Raise your hand. Who will come with me for doing war? Who will win board exam? Come on. Lift your hand with proud, with emotion. You are there with me. Hurry. Yes. So you are responding. That is what I want. Definitely. Definitely. Okay. So next one. So you can go for another one. So another one I'm taking. These are the weapons. So these are the weapons. These are the weapons. Okay. So you know one thing. You are spending your valuable time and responding to me. Okay. So fine. Definitely. You know, most of the cases we have to work so hard. So that's enough. So okay, light reflection and refraction. So I explained this one. Next one, I'm going to the ray rules of ray rules of ray rules of convex mirror. So here I'm said no convex mirror, ray rules of convex mirror. So convex mirror. Ray rules of convex mirror. Ray rules of convex mirror. So I'm taking ray rules of convex mirror. I'm taking one. So here one light I'm taking like this. So one light I'm taking like this. Pole, focus and central curvature. Pole, focus and central curvature. So I'm considering one light ray here. One light ray I'm taking like this. After reflection, it passes like this. It passes through focus. It passes through the focus. One light ray I'm taking after reflection, it passes through the focus. Another light ray I'm taking here. Another light ray I'm considering here. So another light ray I'm taking. So second one. So if it is convex mirror, so convex mirror. So I'm considering here pole, focus and center curvature. Pole, focus and center curvature. So here one more. If light ray is passing through focus, after reflection, okay, so if the light ray passing through the focus, after reflection, it passes through infinity. Coming to the third one, so here you can consider, you can consider, so this is the pole, focus and center of curvature. If the light ray is passing through center of curvature, passing through center of curvature, so here one light ray I am taking like this, another light ray it passes through center of curvature, and the fourth one, if you see the fourth one, if the light ray is reflecting, so pole, focus and center of curvature, pole and focus and center of curvature, pole, focus and center of curvature. So here I'm considering here. So here I'm considering here. So here if you are taking the light ray is incidenting on it, it reflect back. So if the light ray incident on it on the mirror, it reflect back. So the reflector light ray, if you are extending, it passes through the focus. So one more light ray, if it is passing through the focus, after reflection moves towards infinity. So the third one is if light ray is passing through center of curvature. If the light ray is passing through center of curvature, after reflection, it retraces its original path so it passes, like as I said, if the light ray is passing along the normal line, it reflects back into the same path as it is here also same thing. If the light ray is passing along the center of curvature, it reflects back. So here one more thing, if the light ray incident at the pole, it reflects back. Rishi Yadav, definitely I will, okay. So in future, definitely I will work out on it and I will teach. So meanwhile, I am going with the English. So try to accept it. So definitely I'll work out on it. So I'm considering ray rules of convex mirror. Next one we are going for image formations. Image formation I will explain. If you are taking the concave mirror, image formations by concave mirror, image formation by concave mirror, concave mirror. So here I'm taking the image formations by concave mirror. So here I'm taking first one is when the light ray is incidenting on it. So I'm taking here. Pole. This is the pole, focus and center of curvature. Pole, focus and center of curvature. Here you can observe when the light ray is if the object is at infinity, image is, so how the image will form, where image will form, one light ray I am taking like this. After reflection, those light rays will meet at one point. So after reflection, those light rays will meet at one point here. So object is at infinity, image will form at focus. Object is at infinity, image will form at focus. So image will form at focus. Nature of the image is real and inverted. And coming to the size of the image is highly diminished. And coming to the next one, so here I am considering here. Okay, so one pole, focus and center of curvature. So I'm taking one object here beyond center of curvature. Object is placed beyond center of curvature. So one light ray I'm taking like this. It passes through focus. Another light ray passes through center of curvature. The image will form between C and F. Object is placed beyond C. Image will form between C and F. Nature of the image is, sir, is this CBSE or state? Here I have mentioned, Manikantan I have mentioned here. So CBSE grade 10 physics. Light reflection refraction is completely purely related to CBSE syllabus. Whatever I am teaching is completely related to CBSE syllabus. Yeah, CBSE syllabus only. Okay, done. So if the light ray is placed beyond center of curvature, image will form between C and F. Image will form between C and F. Object is placed beyond C, image will form between C and F. Nature of the images. Nature of the images. Nature of the images. Nature of the images. If you are taking nature of the image, so real and inverted, and the size of the image is diminished. Size of the image is diminished. Size of the image is diminished. So that is a second. That is second one. So second image formation. Coming to the next one. So object is placed at C. Object is placed at C. So I'm considering here object, third one. Object is placed at C. Object is placed at C. So pole, focus and center of curvature. Pole, focus and center of curvature. So object is placed at C. Where image will form one light. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Okay. So one light ray I'm taking like this. It passes through focus. Another light ray. So you can take, see, according to textbook only will say, so minimum 2 light rays you can take. But so according to the textbook diagrams you can follow. So textbook diagrams you can follow. So here also I'm considering. So one light ray I'm taking. So according to textbook diagram you can follow. So follow diagrams means completely follow textbook. Okay. So wherever it is, even whatever I'm teaching also, follow the textbook. Follow the textbook notations, textbook diagrams. Because board exam they will see. So board exam they will see the notations of textbook. So that's why follow the textbook. I'm considering here. One light ray is like this. Another light ray, it is passing through that one. So it is passing through that one here like this. So those light rays will incident here. So object is placed at C. Image will form at C. Nature of the images. Real inverted and same size. Okay. So object is placed at C. Image also will form at C only. So nature of the image is real inverted and same size. Very, very important. And here related to this one question I will tell. One question I will explain. So what is the minimum distance? So this question came. Okay. So very, very important question. So that time so we thought like that's different value. But actually many of the students will do mistake here. So here this related to this diagram. So one question, that is, so what is the minimum distance? So what is the minimum distance between real object and its real image? So real object and its image. Real object, so here real image is forming. Real object, so anyway real object and a real image. So the distance is 0. In concave mirror, especially in concave mirror, the distance between center of curvature, the minimum distance between real image and its real object is 0, because object is placed at C, image also will form at C only. That's why. And coming to the next one, so fourth one I'll explain. So fourth one, so if I place the object, so fourth one I am saying here, fourth one I am taking here. So object here, this is the pole, focus and center of curvature. Object is placed between C and F. One light ray I am taking like this. So it passes through the focus. Another light ray, it passes through, it incident at the pole. It reflect back. So where it image will form here. Okay. Object is placed between C and F. Image will form beyond C. Nature of the image is real and inverted. So sometimes see, don't get confused between nature and size. Nature is real inverted. So because upright, so if the object is like this, image will form like this. So real and inverted. So size of the image is in this case enlarged. In this case enlarged because so object, whenever object is placed between C and F, image will form beyond C, beyond V. So in this case, image will form real and inverted and enlarged. So size of the image is enlarged. So this is about uh, object is placed between C and F. And I already said no weapons. So rare rules. Those are very important. In the board exam, they will ask this type of diagrams for 3 marks question. They will ask for 3 marks. They will ask for 3 marks. If you are placing the object, so here I am considering. So here is the pole, focus, and center of curvature. Pole, focus, and center of curvature. Object is placed at F. Object is placed at F. Object is placed at F. Okay, so object is placed at F. Image will form at infinity. One light ray I am taking here, so it passes through focus, and another light ray it incidenting at the pole, it reflect back. So those light rays will meet at infinity. So object is placed at F, image will form at infinity. Image will form at infinity. What is the nature of the image? Nature of the image is real inverted, and size of the image is highly enlarged. Agarwal, okay. So you already called me, right? So we will discuss that one. So in detail, I will discuss. So we will see. Because in 11th and 12th, so whatever I'm explaining these topics, so all the topics are there. All the topics are very helpful. Very helpful, especially for JE. Especially for JE, without these topics, we can't able to do the problem. Very extraordinary topics in plus 2. Whatever I'm explaining, this topic will come in plus 2 optics. Okay, magnetic effects of electric current. So electric charges and fields in plus 2 topic. Okay, and coming to the human and colorful world also related to this one in optics only. So both will be combined and they will ask the questions in so plus 2 topics. Whatever I'm discussing, these are the plus 2 topics. This will be helpful for JE students and NEET students also. So you can concentrate whatever I'm explaining, all the topics you can concentrate. Okay, so focus on the topics, and you already called, right? I will guide you. You can so we will discuss more. Okay, sure. So then object is placed at F. Object is placed at F. Image will form at infinity. So nature of the image is real inverted and size of the image is highly enlarged because image will form at infinity. Highly enlarged. So highly enlarged. So image will form at infinity. Highly enlarged. Next one, we are going to the next one. Next one, object is placed between F and P. Object is placed. So next one, object is placed between F and P. Object is placed. So this is the pole, focus, and center of curvature. Pole, focus, and center of curvature. Object is placed between F and P. Object is placed between F and P. One light ray I am taking like this. It passes through focus. Another light ray it incident at the pole. It reflect back. So this is very important mark. 3 marks question they will ask for board exam. So 3 marks question. Many times they ask this question. Many times they ask this question. Very important diagram. Very important concept also. When the object is placed between F and P. So here I am taking. So if you are taking like this, so the image will form here. The image will form. Object is placed between F and P. Object is placed between F and P. Image will form behind the mirror. Image will form behind the mirror. Behind the mirror. Nature of the images. Nature of the images. Virtual erect and enlarged. Virtual erect and enlarged. So image will form virtual erect and enlarge. Here you can see object is placed between F and P. Object is placed between F and P. Object is placed between F and P. Image will form behind the mirror. So nature of the mirror is virtual erect. Virtual erect. And size of the image is enlarged. Such size of the image is enlarged. Size of the image is enlarged. So 3 marks question. So here and one more. So in the previous diagram, if the object is placed between C and F, image will form beyond the center of curvature. So here object is placed between F and P, image will form. So in this light ray, we are not taking from infinity, object is placed, right? So we are taking object, we are taking particular object, we are placing in front of the mirror. That's why we are taking like that. Through center curvature also there, through center curvature also we can take, as I said. Okay, so here finite object. So object is placed in front of the mirror. That's why we are taking from the object. So that also we can take, but according to the object, we have to take the lines. As I said, what are the light rays we are taking? Follow the textbook diagrams. Standard. I'm saying follow the only textbook diagram. Check the diagrams and draw those diagrams. Just these diagrams I'm explaining how the object, where the object is placed, where image will form. For that purpose I'm explaining. So try to follow textbook diagrams. Clear? Okay, done. So here very important, this one very important, this one. So object is placed between F and P, image will form behind the mirror. Nature of the image is virtual erect and the size of the image is enlarged. Size of the image is enlarged. Okay, done. So next one, we are going to the next one. Concave mirror image formations over. Next one, we are going with the convex image formations. Convex image formations. Convex image formation. So I'm taking here. First one is only convex image formation. Only two are there. Only two image formations are there. One is object is this the pole, focus and central curvature. Pole, focus and central curvature. So object is placed at infinity. Object is placed at infinity. So one light I am taking like this. So it passes like this. After reflection it passes. After reflection like this passes. So if you are extending those light rays will meet at focus. As I said, extending the reflector light rays, okay, makes the virtual image. So if extending reflector light rays will form the virtual image. Object at infinity, image will form at focus. Nature of the image is virtual, erect and highly diminished. So nature, this is the size. This is the nature. Virtual erect is the nature. Highly diminished is the size. Size of the image. Okay. So nature. So two different points. So in the exam they will ask separately. Okay, if the object is placed at infinity in convex mirror, where image will form, what is the nature of the image? Image will form at focus. Nature of the image is virtual, erect and diminished. Highly diminished. Size is highly diminished. Okay. So that is about convex mirror image formations. Only first one. Coming to the next one. So one more diagram is there. So here I am taking the convex mirror like this. Convex mirror. So one is that object is placed at infinity. One more I am taking, this is the pole. So this is the pole. Focus and central curvature. So I am placing the object here. One light I am taking like this. It reflect back. So another light it incident at the pole. It reflect back. So if you are extending this light rays, so here you can consider those light rays. If you extend those light rays like this, if you are extending light rays, so it will passes through focus. If you are extending these light rays, the image will form here. Object is placed in front of the mirror. So like in front of the mirror. Okay, so between P and infinity, anywhere we can place. So P to up to infinity. So here, wherever you want you can place, no problem. So same image formation between P and F only it will form. Image will form between P and F. Nature of the image is virtual, erect. And size of the image is diminished. So once again, nature of the image is virtual, erect and size of the image is diminished. So this is about convex convex image formation, convex mirror, image formation, convex mirror, image formations. Next one, we can go for sign conventions. So we can go for sign conventions. So I'm going to the sign conventions. So very important sign conventions for 3 marks question. They will ask for a board exam 3 marks question. So you can see this one. So here is the concave mirror, concave mirror. So concave mirror. This is the pole, focus. So center of curvature, pole, focus, center of curvature. So here all measurement. First one is all measurement will be taken from the pole. All measurement will be taken from the pole. In the direction of incident rays, all are positive. Object distance, image distance, focal length, and radius of curvature. All are positive. So in the direction of incident rays, object distance, image distance, focal length, radius of curvature, all are positive. Opposite to incident rays, object distance, image distance, focal length, and radius of curvature, all are negative. Above the principal axis, height of the image and height of the object, height of the image and height of the object, both are positive. Below the principal axis, so if you take here and here also, we can take object is placed in front of the mirror, right? That's why I'm taking here. Okay, fine. So I'm placing here. So height of the image and height of the object is positive, whereas below the principal axis, height of the image and height of the object, both are negative. So we can see coordinate axis. This is a so origin, like origin. So this is the positive x-axis and negative x-axis, positive y-axis, negative y-axis. Same thing here also. Same thing here we can take. Same thing here. Whatever we are considering. So here all measurements, here all values must be taken from the origin. Here also same thing, all values must be taken from the pole. In the direction of incident rays, along the direction of incident rays positive, opposite to incident rays negative, above the principal axis positive, below the principal axis negative. Actually, I created a song on it. So with your permission, so I'll sing just 2 minutes. So very important song based on this one. New Cartesian sign convention, new Cartesian sign convention, all distance measured from the pole. Distance are positive along the instant rays. Distance are negative opposite to instant rays. Distance are positive above the principal axis. Distance are negative below the principal axis. This is the song. So to remember the concept in easy way, I created this song. So like so many songs I created on a concept. So this is one of them. I will sing once again. New Cartesian sign convention. New Cartesian sign convention. All the distance measured from the pole. Distance are positive along the instant rays. Distance are negative opposite to instant rays. Distance are positive above the principal axis. Distance are negative below the principal axis. So that is a song. Thank you so much for listening this song. Okay, so that is about new Cartesian sign convention. See, so these are not only Normal, see, in the exam they will ask about a new Cartesian sign convention. Explain about new Cartesian sign convention. Nothing but sign convention only. So no need to worry about it. That is about sign convention. So sign conventions. So along this incident rays positive, opposite incident is negative. Above the principal axis positive, below the principal axis negative. All measurements will be taken from the pole. All measurements will be taken from the pole. So that is about sign conventions. And coming to the next one. So we'll go with that. Magnification. Magnification. So magnification is nothing but m equal to so height of the image by height of the object, and a mirror formula. So 1 by f equal to 1 by v plus 1 by u. Mirror formula equal to 1 by f equal to 1 by v plus 1 by u. So magnification is nothing but height of the image by height of the object, nothing but minus v by u. Minus v by u. So these are the magnification and mirror formula. So until here, so reflection is completed. Reflection is completed. Till now, whatever we are discussing, reflection topic only. So refraction topic now 7:43. You observe now. As I said no, so more than 8 o'clock it will take. Now 7:43. Still it goes one more hour. So one more hour. So if you wanted me to continue, I'll continue. Otherwise, 9 o'clock class. So if you want to join, you can join. So according to your opinion, I will take. Is it okay? Shall I continue or 9 o'clock class? Reflection. How it is? See, if you start the concept, it goes. It never ends. Definitely, it won't end. So until 9 o'clock, it will take. Again, from 9, I have to teach. No, again 9, I have to teach the light reflection diffraction. So what we can do? We will stop now. So we'll stop now. Again, 9 o'clock, you can join to the class. So those are there. You can join to the 9 o'clock class. So we'll discuss the light refraction chapter. Shall we? Nobody is answering. Why? What happened? So okay, done. By voting of the people, so we decided we'll go to the light refraction on at 9 p.m. Okay, so see you in the 9 p.m. class. So this is our Shiva sir. If you like this video, please do like, share, and subscribe to my channel, Student the Brand. Please support. I need your support. So please spread a word about this channel. So thank you so much. Namaste.